Hi everyone, let's solve today's daily challenge, that is number of enclaves. So in this question we are given a m cross n binary matrix grid. That is it is a binary matrix, so it will contain zeros and ones only. So wherever you find 0, that is a C cell. That means wherever there is a 0 in the grid, you should know that there is water present. Similarly, if there is 1, so we can say that that is land cell, right? Then they have considered a move, right? So what is a move? Move means you walk from one land cell to another adjacent land cell, right? So let's see first what the adjacent means here. So basically, let's say you are at this particular cell. So if you move here or here, I am just talking about adjacent here, right? What is 4 directionally adjacent? So these are 4 directionally adjacent that they are talking about. That means that if you move up, down, left or right, correct? They are adjacent to this particular value that we are currently at, right? So what is one move? You can move from one land cell to another adjacent land cell. That is, see, this is a land cell. Wherever one is, that is a land cell. So you can, so a valid move will be from this particular one to this one. Just a minute. Right? From this particular one to this particular one if you move, or if you move to this particular one. So these both are valid moves. And what is the second thing that they have mentioned? That you can move from one land cell to walk out of the grid, right? So you can also say that, let's say you are standing in this particular cell, right? So where can you move? You can definitely move to this cell, and you can also move out of the boundary of the grid, right? So that is also a valid move. Now let's see what we have to do in the question. We need to return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves, right? So basically what they have said is you have to find all those ones here, right, which do not lead you out of the boundary of the grid, right? So see, let's see what the question means. Right. Now, let's say you are standing in this particular one, right? If you're standing in this particular one, what are the valid moves? You can move here, right? You come at this particular one and you move out of the boundary, right? So that means these both one that you cannot consider in your answer because these lead you out of the boundary of the grid, right? Similarly, if you see this particular one, this also leads you out of the boundary. We will not consider this also in our answer. Here also you can see that this one leads you out of the boundary, not the answer. Right? Now, if you see this particular one, definitely leads you out of the boundary. Now see, for this particular one, where can you go? You can move to this one, right? And from this, you can move here. And this one takes you out of the boundary. So basically, both of these ones, right? This and this, you will not consider in your answer because they are leading you out of the boundary. Similarly, this particular one, if you move from this one to this one, and then you can see again it leads you out of the boundary. Now check for these two ones here. Let me change the pen. If you check for these two ones, from this one, you can move to this one, correct? Now, if you have moved to this one, where else can you go? You can again move to this one, but you see that any number of moves you do, you cannot go out of the boundary of the grid, correct? So that is what we have to basically return all those land cells which don't lead you out of the boundary of the grid. So basically here the answer will be 2 because you can also see the land cells which are not leading you out of the boundary of the grid, right? Now let's see how we will be solving it. Sorry, I have a bad throat today. Okay, wait. Now one thing you can notice here is that, see, if you take the first column, the first row, right, the last column and the last row, right, if you consider these, right, so whatever land cells are present here, you know that they will be leading you out of the boundary of the grid, right? That is very sure. We are very sure of that. But we don't know for the inside ones, right? For example, this particular one. in 2 moves you can move out of the boundary of the loop, right? Sorry, out of the boundary of the grid, correct? So for those ones we have to check, right? But for all those one, right, or all those land cells which are present at the boundary of the grid, they are definitely leading you outside of the boundary, right? So here we can say that these are kind of, if you like, see, if you go from this land cell and you consider all these land cell, you can see that this is kind of a one connected component kind of a thing. Similarly, if you see here also, you can see this is kind of a connected component thing, and here also this particular one will be taking you out, and also this one. So you can say that somehow we are trying to see connected components here. So can I say that we can solve it using graphs, right? Only graphs deal with connected components, correct? Yes, so we'll be solving it using graph. Now now let's see what we'll be doing. So one thing that you can do is you can simply traverse in the first column, in all these like 4 columns and rows, right? You can traverse there, you can find each and every land cell, and from there you can perform a DFS or a BFS traversal, right? So that is a very easy solution. But in this video we're going to discuss multi-source BFS, right? So it is normal BFS, but in multi-source BFS what we do is, now see, we have, okay, wait, let me use another pen. Okay, see here. So here you can see that we have this particular one. Okay, this is not visible. Let's take a yellow one. So if you see this particular one here, right? So you'll be performing DFS or BFS from here. You see this particular one. You see this one, this particular one, and this particular one. So what I said, what you will do is you will simply target these ones individually and then you will do a DFS or BFS. But in multi-source BFS, you can simply put them together inside of the queue, right? You can say that, so in normal BFS, you take one node, right? And from that one node, you traverse, correct? But in multi-source BFS, you can take different sources, right? You can take different nodes and from there you can traverse. So what we will do is we will simply put these, right, all these ones inside of the queue, and then we will perform BFS. So it is similar to normal BFS. It's just that we are choosing different sources initially, correct? So that is all the intuition of the problem and logic of the problem. Let's see it in action here, right? Now first what we have to do is we have to create a queue, correct? Oh sorry, we will create a queue for pair, and that is because we have to store wherever we have to store a element of the grid, right? So we'll have an IJ format here. Okay, wait, we'll be having an I comma j kind of format, right? Okay, so we have our queue here, and then what we will do is right, so after this we have declared this queue, we will also declare a visited array, right? We'll also first let's take the number of rows and columns, right? So n has the number of rows, and let's take the number of columns here, dot size, right? Now let's declare our visited array. So our visited array will be vector of vector int visited, size will be n comma int m comma 0, right? Now so we have declared our visited array. Now what we will do, we have to first what we have to do is we have to put all these ones that are present in the first row, the first column, the last row, and the last column, right? We have to put them inside of the queue, right? So for that, let's write a for loop, right? I less than n and I plus plus, and then we'll have int j is equal to 0, j less than m, and j plus plus. Now, now how will we know that if it is first row or first column or last row or last column? So we can simply check if I is equal 0, will be on the first row. If j is equal 0, then we will be on the first column. And similarly, if I equal n minus 1, then that is last row. And if j equal n minus 1, then that is last column, right? So if we are in these particular rows and columns, and the value of grid is 1 here, that is if a land cell is there, then what we have to do, we have to put that particular land cell inside of the queue, right? and grid I comma j is equal 1. So we will say q dot push I comma j. Now next thing what we will do, next thing, so because we have put these values inside of the queue, we have to mark them as visited. So we'll say visited I comma j is equal to 1, right? So now we are done with this, with our first step of the BFS. Now what we will do, we will write the logic for BFS. So you just take a while loop, right? And until your queue is not empty, right? Until your queue is not empty, you have to keep traversing here, right? So first let's take whatever value is in the front of the queue inside two variables. So that is the first value inside of the this pair value inside the queue is our row, and the second value is of column. So we are just taking them outside of the queue. So we'll say int row is equal to q dot front dot first, right? So we'll be getting the the row value, right? And then we'll say int call is equal to q dot front dot second, right? Now okay, so now we have done this, we will pop this element out. Now we have to do what? We have to check the adjacent cells, right? So for adjacent cells, let's create the directions, right? So we can have 4 direction, right? So the one direction is I plus, okay, let me write it here. So you have 4 directions, that is I plus 1 j, I comma j plus 1, right? Then you have I minus 1 and j, and you have I minus 1 okay, wait, I comma j plus 1, right? So we have these 4 directions, correct? This direction, this direction, this direction, this direction, right? So for that, what we'll do is we'll simply create 2 vectors here, right? So we'll have vector int, let's call it dx, right? Inside of this, what values will we have? Well, 0, 1 and 0 and minus 1, right? And also create another vector int dy. In this, what values we'll have? We'll have 1, 0 and minus 1, 0. So this will be covering our all 4 directions, right? If you consider the ith value in both of these vectors, so what will happen? You will have 0 comma 1, you will have 1 comma 0 and 0 comma minus 1 and 1 minus 1 comma 0, right? So we will get all our 4 directions using these 2 vectors. So what we'll do, we have to traverse in these 4 directions, right? So we will be getting our adjacent elements. So we'll say int I is equal to 0, I less than 4 and I plus plus. Now what we'll do, we'll calculate our adjacent row and column, right? We'll say adjacent row is equal to, so this loop will be calculating all the adjacent 4 directions, right? So we can simply, add dx and dy to adjacent row and adjacent column, right? So we have adj row. So here what we'll do, whatever value in row we have, we'll add dx to it. And similarly, we'll take adjacent column, which will have column plus dy, right? So this will give us, these two variables will give us the adjacent row and column values. Now what we have to do, now see, first what we have to check is that whatever is the value of this adjacent row and adjacent column, they should be in bounds, right? For example, if we were currently at this particular cell, then if you take the upper cell, that is not inbound, right? So first we need to check if these are inbound or not. So we'll have 4 conditions, right? That is adj row should be greater than equal to 0 and adj row should be less than n. Similarly for column, we'll do adjacent col should be greater than 0 and an adjacent col should be less than m, right? And also that particular cell that we are, this particular cell, adjacent row comma adjacent column, it should not be visited and it should be 1, right? So let's also check that. In grid of adjacent row and adjacent column, it should be 1, that is, it should be a land cell and it should not be visited. So we'll say with adjacent row and adjacent column, it should be not visited, right? Then what we have to do, then we have to push it inside of the queue, right, for further VFS. So we'll say if all these conditions are true, just push it inside of the queue. Queue dot push whatever values we have of adjacent row comma adjacent column, right? And also we will mark this as visited, adjacent row and adj column. This value will become 1, right? Now after this BFS traversal is done, that is after the queue is empty, we will be left with these cells. We will be left with these 2 cells, correct? So basically these 2 cells will be 1 inside of the grid, but because we are doing a BFS traversal, whatever, one lead you out of the boundary will be inside of the BFS traversal. That means in the visited array, they will be marked as 1. But these values which are not leading us out of the boundary will be 0. That is not marked, right? So that we will use these 2 values, right? We will check if they are whatever land cell, right? Whatever the remaining land cell are which are not visited, their count will be our answer, right? So let's first declare int ans, which will be initialized to 0. Then we have to simply traverse from int I is equal to 0, I less than n, I plus plus. For int j is equal to 0, j less than m and j plus plus. What we have to check? We have to check if grid of I comma j, it should be 1 and also it should not be visited. That is, in visited array, its value should be 0, right? If this is so, right, if we find any this cell, that means we have to include it inside of our answer, right? So we'll simply say ans plus plus, and after this we will return ans, right? So that is how we have to solve this question. So let's quickly run it. Okay, wait. So here we have to take ith value from the dx array, right? And also from the dy array. Now let's run it. Okay, so we have to check if this is equal 0, right? So now this should run. Okay, so this is accepted. So this is basically how you have to solve this question. So what we have done multi-source BFS, and we have simply checked from the visited array and our grid, whatever land cells are remaining which are not visited, they will be counted as answer.